Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over how to balance a redox reaction using the half reaction method in acidic solution. So let's get into this. So this is the second problem. So in a previous video I did a problem where I balanced a redox reaction in acidic solution, and I'm going to do it for this one as well. This one's going to be a little bit different because this time we're actually going to need to use water and H plus to balance our redox reaction. So let's get into this. So the first step is to identify what the oxidation states of your atoms are in all of your substances. So again, if you have monoatomic ions, that is ions that are made up of only one atom, they have a charge, then the charge is the oxidation state. So we have manganese with a 2 plus charge, so the oxidation state is a 2 plus. And we have the charge on the iron, and the iron also that charge is going to be the oxidation state for the iron. Okay, and the same thing with the iron, with this iron here as a 3 plus, so the oxidation state for this iron atom is 3 plus. Okay, now for atoms that are in a polyatomic ion or in a molecule, you got to identify what the oxidation states for those are. Now, there is a priority set between the atoms, and so you got to know the priority and label the oxidation states accordingly. So oxygen as part of a molecule or part of an ion, with the exception of peroxides, will always have a -2 charge. So we give oxygen priority over the metals, and so we give oxygen a -2 oxidation state. So there you have the -2. Now we have 4 oxygens in this polyatomic ion. So since you have 4 oxygens and each one has a -2 oxidation state, that means that the total negative charge, if you will, is a -8. So this means that the manganese, overall, the oxidation states of the manganese with the 4 oxygens has to total the charge on this ion. And the charge on this ion is -1. So if we have a total of a -8, what plus -8 gives us a -1? Well, that's going to be a +7. So that means that the oxidation state of the manganese here is a +7. So now we've figured out what the oxidation states of all the atoms are. We can divide this equation into 2 half reactions: oxidation half reaction and the reduction half reaction. So we're going to use our mnemonic devices to figure out what is reduced and what is oxidized. Okay, so if oil, or I think oil, I used oil rig last time, I'll use Leo-Gur this time. So Leo-Gur, loss of electrons is oxidation. So what lost electrons? If something loses electrons, it becomes more positive. So what becomes more positive here? Here we have iron. Iron starts off as 2 plus, but then it becomes 3 plus. So that definitely became more positive, right? So that means oxidation. So we're going to write that half reaction here. So Fe 2 plus aqueous goes to Fe 3 plus aqueous. Okay, good. Now we have that one. And we can identify which one is reduction. Gain of electrons is reduction. Well, if we look at manganese, manganese started off with a +7 charge here. And now it ends up with a 2 plus charge. So gain of electrons is reduction. So if you gain negative electrons, that means you become more negative, or another way to put it, less positive. So the manganese here is going from +7 to +2. That's less positive. So therefore, that's undergoing reduction. So we then write the half reaction. We take this whole thing, MnO4 minus aqueous goes to Mn2. So Mn2 plus aqueous. Okay, so second step, we've divided up our reaction into two half reactions. So now we need to balance them. So we're going to balance the atoms first, and then we're going to balance the charge. So oxidation, we'll start with oxidation. So let's balance the atoms for oxidation. Look, it's already balanced. We have one iron. The only thing that differs is that the charge on the iron atom is different. But we have one iron atom here. We have one iron atom there. So that's already balanced. So why don't we come over here? So now over here, we have to balance the number of atoms on both sides. So the manganese atom and the manganese atom is already balanced. We have one each. But look over the oxygen here. We have 4 oxygen over here and no oxygen over there. So the way we're going to balance oxygen is we use water molecules. So we're going to add enough water molecules on this side to balance the oxygen. Since we have 4 oxygens over here and each water molecule has 1 oxygen, that means we need 4 water molecules. So we're going to add 4 H2Os. And that's going to be liquid. Okay, this is happening in an aqueous liquid solution with water, lots of water, so that's going to be available. Now we have 4 oxygens, but look, we just added 8 hydrogens from the water, and we don't have any hydrogens over here. So this is where the acidic solution comes in. So the acidic solution has H plus ions in it. So we're going to add H plus ions over here to balance the hydrogen. Since we have 4 times 2 is 8 hydrogens over here, therefore we need to add 8 hydrogens over here. So we're going to add 8 H plus aqueous. So now we have 8 hydrogens, 8 H pluses over here. That balances the 8 over here. So now everything is balanced. We have all the atoms balanced. So now we have to balance charge, and we're going to use electrons to do that. So let's go over here to balance the charge. So we have iron 2 plus, and we have iron 3 plus. We can only use electrons. So we have negative electrons. Which side are we going to add negative electrons to equal out the charge? We're going to add it here. So if we add 1 electron, 1 negative electron on this side, now we have -1 plus 3 plus gives us a total of a 2 plus on this side, which balances the 2 plus on this side. Okay, so now we have our balanced charge on this side. Now, what about over here? So we need to balance the charge on this half reaction. So I'm going to draw a line here so that we can distinguish between our two halves. So let's count the charge on this side. So I have 8 positive over here plus 1 negative. So the negative and the 8 positive gives me a total of a positive 7 on this side. Okay. And then over here I have 2 positive plus I have neutral water, it has no charge. So over here I have a total of 2 positive. Right? So positive 2 on this side. So since this side is more positive, I'm going to add the electrons this side to lower the positive charge to equal 2. Well, how many electrons do I need to add? 5. So 5 negatives plus 2 plus a 7 positive is going to give me a positive 2. So let me write it here. So I'm going to add 5 electrons plus the 8 H plus aqueous plus the MnO4 minus aqueous is then going to give rise to Mn2 plus aqueous plus 4 H2O liquid. So here's my balanced half reaction here, my reduction half reaction. So I have 5 electrons. Everything is balanced. So I have balanced charge and balanced atoms. For this one, I have balanced charge and atoms for this one. Now I just need to make sure that the electrons for both halves are equal. I have 5 on this side, but I only have 1 here. So I'm going to have to multiply this half reaction, my oxidation half reaction, by 5. So multiply that by 5, and I get 5, I get 5 iron 2 plus ions aqueous plus, not a plus, and that's going to go to 5 Fe3 plus aqueous plus my 5 negative electrons. Okay, so now I have 5 electrons in the product side on this side, and I have 5 electrons as a reactant side on this side. So when I add these together, the electrons on both sides will cancel each other out. So 5 and 5 get canceled out. So now I add these back together. So here I have my reactant. So that's 5 Fe2 plus aqueous, and then I add the reactants that I have on this side. So my 8 H plus aqueous plus my MnO4 minus aqueous. So I have my reactants all on one side. Now the products. So over here I have 5 Fe3 plus, 5 Fe3 plus aqueous. So that takes care of the products on this side, and then I have products on this side. So I'll add the Mn2 plus aqueous plus the 4 H2O liquid. And there you have it, ladies and gentlemen. This is the balanced redox reaction. So you can double check the numbers, right? So you can say I have 5 irons over here, I have 5 irons over here, I have 8 hydrogens here, I have 4 times 2 is 8 hydrogens over here, I have 1 manganese, and I have 4 oxygens. 4 times 1 is 4 oxygens. And as far as charge goes, I have 5 times 2 is 10 plus 8 plus here, that's a total of 18, minus 1, that's going to be 17 plus. Over here, I have 5 times 3 is 3 plus the 2, that's 17. So both sides are balanced in charge. So that's it for this video, this problem. I hope this helped you a lot. If you enjoyed this video and this was helpful in any way, then please, by all means, like the video, share it with your friends, hit that like button over there somewhere. Also, subscribe to my channel, hit that notification bell, select all so you can be notified by all my videos that I post. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me, and have a great day.